Hello, this is from Vijayakumar, Assistant Professor, Head of the Department of Physics, SNS College of Engineering. This video is another one topic of laser and fiber optics, principle and propagation of light in optical fiber, numerical aperture and acceptance angles. First, we discussed in what is an optical fiber and total internal reflection and propagation of light through an optical fiber. This is all we discussed. Then after we entered from that the optical fiber topic. So the introduction of optical fiber is a cable by which light signal can be communicated from one place to another place without any losses of energy or intensity. The principle is total internal reflection, and to condition the light move from more denser medium to less denser medium, the angle of incidence is much greater than critical angles. Based on the principle of TIR, the ray which incident angle greater than critical angle at the glaring core interface can be transmitted. It depends on the core radius, the numerical aperture of the core, and the wavelength of light stimulated in the fiber. So this is the block diagram how the ray will be transmitted and communicated from one end to another end. The numerical aperture is defined the sine of the angle of fiber light acceptance cone. So the NA equal to theta A. Theta A is an acceptance cone of angles. Then we start from the derivation of finding numerical aperture and acceptance angles. So the applying of Snell's law, we get in a 2 point of A and B, we get the numerical aperture value is equal to root of n1 squared minus n2 squared with respect to the form of three different refractive index of the transmission. One is in a refractive index of air, that is n0, n1 is in a refractive index of core, and n2 is a refractive index of cladding. So the optical fiber base, the two refractive index is very important. One is n1 and n2. Especially n1 is very important because that is a refractive index of core. So the parameter of optical fiber we have get from the derivation part of that. One is acceptance angle, sine theta A equal to root of n1 squared minus n2 squared. Acceptance angle, acceptance cone is equal to 2 theta A. The numerical aperture is sine theta A. Then skip distance L equal to d root of n1 by n0 sine theta 1 whole square minus 1. The number of reflection mode n equal to 1 by d root of mu1 by mu0 sine theta 1 whole square minus 1. So the acceptance cone, these are the white light, that why I am framing the VIBGR inside of the cone. The same it's formed in that the opposite side of the cone to be entered from that inside of the core regions. So this is the formula to form in sine theta A equal to root of n1 squared minus n2 squared. Theta A equal to sine inverse of root of mu1 squared minus mu2 squared. So the numerical aperture means is an light gathering efficiency of an optical fiber, maximum light to be gathered and to be transmitted of optical fiber, that is a numerical aperture. Acceptance angle, the maximum light to be transmitted in upward and downward direction, it's a form of imaginary cone. That cone is an acceptance cone. So the acceptance goes based on the acceptance angle of top and below. It is an incident angle of the optical fiber. So this ray is not intermediate in inside of the optical fiber because the different angle to be incident of optical fiber. So it's not interfere, the maximum wavelength and interference we get from that one end to another end without loss. That why is a form of optical fiber. So the optical fiber application is more. So we have followed from this based on the properties and some important introduction wise, we get some idea why we have used in optical fiber in different regions, especially in endoscopy, bloodless surgery, communications, like that. Because the losses is very low but the gain is high, right? So this is a reference. I prepared the PPT to expose of the numerical aperture and acceptance angle. Thank you very much. We discuss in another one topic in another video. Thank you.